Alrighty, shall we get started? Hi everyone, welcome to another week of DSCov. My name is Paul Xu, and I am a data scientist at CCV. And today I'm going to talk about the Napari image viewer. So you might be asking why you're excited about an image viewer. Even my browser can do image viewing, right? But Napari is much more than just an image viewer. First, it specializes in high-dimensional images. So folks in the medical and biosciences might have lots of volumetric images or have like images that are collected over time that they want to visualize. And Napari is very good at specializing in that. And also, you can also extend the functionalities of Napari to make it fit into your workflow, and even publish that workflow to share it with the others. All right. So today, hopefully by the end of the hour, you're going to agree with me that Napari is another valuable tool that you can add to your workflow. So here's our plan for today. So first, I'm going to give you a brief overview of what Napari is, why we want to use Napari over other tools. And then we're going to do a demo of Napari. We're going to go through the basics of Napari and take a look at how do you work with Napari. So that includes loading multidimensional images and viewing them in 3D. And adding different layers to it and customizing its interface so that you can extend the functionalities of Napari. And then we have a few more advanced features, such as loading very, very large volumes of images that don't fit into your memory. Napari is also very good at that. And in the end, I'm going to introduce you to Napari Hub, where you can find hundreds of Napari plugins that are developed by other developers. So you can extend the functionalities of Napari as well. OK, so here is the question. Why Napari? You might ask, I'm already using blah. So why am I going to learn this new tool? So for me, I think the biggest reason why you choose Napari over any other tool is that it is programmable using Python. And by using Python, you have access to a large collection of excellent image processing packages that you can use to extend the functionalities. And also, because you're using Python, there's no stopping you from using, for example, like deep learning packages with which you can visualize the result of your deep learning models as well. And also, Napari is very good at providing multidimensional image support. You can view images in 3D, and even with higher dimensional images. So, for example, 3D images over time, so for like 3D videos, Napari can handle that as well. And if you're familiar with like Python GUI applications, you might have an impression that they are slow, sluggish, but Napari is nothing like that. It's based on PyQt, and it has excellent GPU support, so you have a very snappy user interface as well. And also, you can stack different images or different types of annotations, informations. They're called layers in Napari, so you can basically stack them on top of each other to provide more sophisticated data visualization. And it also supports distributed out-of-memory computing, so that you can, so if you have large images that don't fit into your memory, you can view them as well. So all this comes within a very, very customizable user interface. So it is very easy for you to add your own functionalities to Napari and we will see examples of that. In the end, we have also a lot of plugins available through Napari Hub that you can install as well. All right, so how do you use Napari? So there are 3 major ways for you to use Napari. There is a Napari standalone app that you can download and install, and it is available for all platforms. But by using that, you do have some of the functionalities of Napari, but you also lose the best part of it, which is the Python programmability. So we recommend that you definitely use it as a package in Python. And with that, there are 2 ways. First, you can script it and then launch that user interface. But what we're going to do today is that we're going to use it with Jupyter notebooks. And the advantage of doing that is that Napari has a 2-way binding with the Jupyter interface. So whatever changes you make to your Napari session, it will be reflected immediately. And likewise, if you have made some changes in your Napari user interface, it will be reflected in your Python, in your Jupyter notebook as well. So it works very well as a 2-way binding mechanism. And it's very easy to install. We recommend that you install it with Conda or with pip. Yeah, Camilo.
What's the minimum Python version in order to run
That is a good question. I think the more popular Python versions, more recent Python versions, it will support. So I tested it on Python 3.7, 8, 9. It all works. I'm not sure about earlier versions as well. So, all right, great question. Any other questions? All right, okay, so we recommend that you install it with Conda because it depends on the PyQt package, which might sometimes not install, for example, on M1 Max. So in order for maximum compatibility, we recommend that you install it with Conda. All right, and today we're going to run a few examples on Oscar, and we highly recommend that you use Oscar with Napari. And there's a few ways that you can use Napari on Oscar. What we recommend is that we use this new Open On Demand desktop that I'm going to show you in a moment. You can definitely also use the VNC to log into your Oscar session as well, but that is going to be deprecated soon. So, but what will not work on Oscar is if you load a command line, even if you set up X forwarding, it is just not going to work. And if you use Open On Demand, but if you load just a notebook session, it's not going to work as well. So a desktop environment is definitely necessary for Napari. And you can also install Napari on your own computer as well. Yeah, please.
You just add a little bit as to why X forwarding or any kind of standard GUI forwarding wouldn't work?
I don't really know. I tried it, but it just didn't work. I think there's something that happens with PyQt compatibility with the X forwarding. So, and I think the GUI is also a little bit more sophisticated. So it just doesn't work very well with X forwarding. Yeah. All right. Excellent question. All right. So. Now let's just all kind of get started with just demo session. I'm going to run through a Jupyter notebook, but that Jupyter notebook is already available at this repo right here. So if you go to that tiny URL link, you will get to that repo, and that it has all of the instructions that you need to set up in an Oscar desktop. So I'm just gonna. So if you have an Oscar account, please just follow along. I'm going to show you how to just get started with this repo on Oscar. Okay, so first you just go to the ood.ccv.brown.edu. So this is so after you log in, you will see this screen, and what you want is the desktop app. So please just click on this desktop app. And then it will ask you what kind of instance you need. So for this purpose, let's just launch a GPU instance, because GPU definitely accelerates the computation. So it will make the user experience much more smoother. And then you can click on launch. Oh, by the way, the non-GPU instances will also work, but GPU just works a little bit better. So after you click on launch, Oscar will work very hard to get you to this screen, from which you can just launch your desktop. And what you will see is this desktop. And then within the desktop environment, you can clone the repo, and then you can follow the instructions in this repo to get your development environment set up, and then you can just launch Jupyter, and you will be seeing the same thing that I'm looking at right now. Mm-hmm.
I didn't have Conda installed.
Yeah, okay, yeah. So you can load the module, but I've already written a script for you. So if you just launch a terminal, and if you just do, so let's just go into, and if you just do bash load, and it will load. It will load the module for you, but you need an additional step, which is loading the loading. I've already created a Conda environment for you on Oscar. So if you just activate that environment, which is and then you will have that Conda environment. And that has all of the dependency you need. And you can just launch the Jupyter notebook, and you will see this.
Well, I wasn't even able to use Conda because I don't have it. I'm installing. I just installing a Conda have the command.
Okay. So you can use module load to load the Conda here. Yeah, and then you will have Conda available to you. Yep. In the meantime, if you have any questions about setting this up or about Napari in general, please feel free. Okay, are we all good? Good? All right, awesome. Okay, so let's get started. So a little bit of the context for this notebook. This is actually a real-world context. It is a project that I'm working on with Dr. Alexander Fleischmann's Fleischmann's group. And the task is basically to use machine learning to kind of identify the cell nuclei in 3D scans of mice brains. So basically, our goal right now with Napari is that so we have the ground truth of all these cells, and we've done image segmentation to produce a lot of predictions. So basically, what we want to do right now is that we want to visualize both the ground truth and the predictions on top of the original brain image, which is in 3D, so we can qualitatively inspect how our model is performing in this task. So, okay, so let's get started. So first, let's just load all of the dependencies that we need, and then we're just going to load our images, ground truth, and also the prediction. So image in this case is just a TIFF image, but it's a 3D TIFF. So we can use the scikit image package to load it into a NumPy array. And the ground truth and predictions are basically just NumPy arrays. You can think of it as a 3D cloud of ones among a sea of zeros, and wherever it is 1, it is basically just a prediction of a cell nuclei there. So if you load everything, you can see that the dimensions of the image, ground truth, and prediction are the same. So that sets up for us to kind of put one of them on top of each other. All right. So after loading your image as a NumPy array, so Napari accepts NumPy array or anything that provides a NumPy array interface. So basically, right now you just use the view image function in Napari, and you will be able to load an interface. You will see that this very, very dim right now brain 3D scan of a mice brain. It's actually just one region of interest in the allocortex of the brain. But right now, as you can see, it is very dark, right? So Napari provides you with some functionalities to kind of like adjust the contrast, so you can see it a little bit more clearly. But as I just said, this is a 3D image. So can we actually view this image in 3D? Right. So let's first just check, just inspect this image in 3D. So here's a button on the bottom left. Is a toggle and display, and you can just click on that. Then this image will be visualized in 3D for you, and by 3D I mean you can actually just adjust it and zoom in and out. So you can see that this is really an image that's in 3D, and you can see the individual cells. From this visualization. Yeah, please think. Sorry? The file format. Okay, so anything that you can load in, that you can load into like a NumPy array, it will support. So for loading the image, it actually depends on other packages. So for example, you can use TIFF file, right? You can also use you can also use scikit image. There's also other kind of packages that provide that kind of functionality as well. So yeah, so that's so as long as it is eventually turned into a NumPy array, it accepts. So All right, so and there's a few other functionalities that you can use in Napari to kind of view the image. So for example, if you go back to this 2D, and then you will have this, dimension slider, which allows you to kind of go through each of the individual slices on the z-axis. So right now you're looking at the images on z-axis. And also, you can view this image from different angles. So right now, it's a top-down view. But if you want to look at this image from the side, you can definitely do that as well. Yeah, please.
Maybe this is looking ahead a little bit.
Mm-hmm.
This is a Z-stack.
Yeah.
Typically, it comes with metadata, like, for example, how far are the Z-planes from each other. That would get lost in the generic NumPy array. So
Yeah.
something else going on here for it to know how to do the stacking?
So from what I understand, it does the interpolation right here, and actually you can see this right here. You can choose different ways of, I think that's how they kind of glue together the z-axis. It does the interpolation. Here you can use different kind of algorithms to do the interpolation as well. That's how I understand. I'm not sure. I could be totally wrong. Mm-hmm.
I mean, again, maybe this is a fine detail, but specifically for this kind of data, it's common for the pixels when you're looking at a single image to not be the same scale as the spacing between planes.
Yeah, absolutely.
So is there a parameter here somewhere that says where you can tell it how much distance there is between each successive plane?
I don't think that's available right now, but that is a very, very good point. Yeah, and you can see that in this one, the resolution on the z-axis is actually not at the same as on the other axis. Yeah, I'm not sure how they are fixing that problem. Yeah, but that's a great question. All right. Okay. So and there's a few other things you can choose as well. So for example, this you can transpose the axis, and then if you have done, you can also go back to your original view by clicking. So let me just show this. So for example, if you have changed your view, but if you want to go back to the original view, you can actually click on this home button, so you can go back to your default view. Yeah, and there's a few other things that you can play with as well. So for example, you can change the color mapping for the images, so it looks a little bit different to you for your different visualization purposes. All right. Okay. So that's basically how you load an image and how you actually adjust different parameters to so that your image looks okay. So next. So we just said we want to add different layers on top of each other to visualize different things. So now let's add a ground truth layer. And the way to do that is that so when you did view image, it returns a viewer object to you. So all of the work in Next can happen on the viewer object. So from the viewer, you can just say viewer.add labels. We're adding a label layer. So there's different types of layers in Napari. What we're adding right now is a label layer. And label layer is basically just like individual pixels that do not form any specific kind of shapes. So you can use labels to represent that. Okay, so after doing this, you can see that the labels have already been added, but also they don't look very good right now, right? So what do? We can actually change the color mapping of the layer to customize it so that it looks good to you. So for example, right now the labels are integers 0, 1, 2. As you can, if you're doing image segmentation, there's also these numbers could represent different classes as well. So you might want to map them to different colors, right? And the way to do that is just to use a dictionary as a color map and then add it to the layer. And you can specify the color as green, or you can use a 3-tuple with RGB values, or a 4-tuple with RGBA values, with A being the opacity of that color. So let's just say whoops. Yep, but you can see that we have a different color for all of the labels in this image. And then all of the images, all of the layers are displayed here, so you can adjust the order of different layers and change the name of the layer, or you can toggle the layer on and off if you don't want to see any particular layer. Yeah, and also you can adjust the overall opacity of the layer as well, so it does not obstruct the view of your image. And of course, you can view this layer in 3D as well. So you can see the ground truths are also like it's 3D blobs in a 3D space. Yeah, so let me just quickly go through what each different types of layer does and how they fit into different workflows. So you have the very basic image layer. You can just add a layer, add this image to the viewer, and then we just saw the labels layer. But so the next couple of layers fit into your annotation workflow. So for example, if you want to annotate points on the layer, you can use the points layer, or if you have a image detection workflow in which you want to annotate bounding boxes, you can use the shapes layer to do that. And then surface layer is just a multidimensional generalization of that. You can pass it like multidimensional kind of meshes to add to the image as well. And if you do, for example, like cell tracking or ice flow tracking, or in general like object tracking, you can also visualize the tracks between different frames. If you think of the image as like as a video, you can use the tracks layer to do that. And also we have this vectors layer, which I cannot think of too good use case, but if you work in meteorology and you want to visualize, the direction and the strength of wind and things like that, you can use the vector layer to do that. So all these APIs have very similar all these APIs have very similar APIs. So you can use viewer.add blah. And then you just put the type of the layer in there, and then you can just add the image to add that layer to the viewer. And of course, and then if you use Napari.view something, then it will return a viewer object for you to do to work with later. But if you use viewer.add something, it will return you a layer object, and then you can edit that layer object to customize how you want these layers to be displayed. Okay, so that's basically how you, so let's just add another layer here. So our task is to, so right now we basically put the name and color as argument to the add labels function, and it will do the same thing. And right now you can see all of the labels and the predictions being visualized. And you can see that while they do overlap a lot, you can see a lot of like predictions in places where there should not be a prediction. So that means the model is actually over predicting a little bit. And so this is very helpful information for us to kind of fine tune our labels later. All right, any other questions so far? Yep. Yeah, actually, we can just get to that right now. So if you want to, so right now you can actually draw on the different layers. So let me just remove this ground truth layer. So for example, if you want to draw on the predictions layer, the way you do that is go to predictions, and then because this is a label layer, you will have a few tools that you can use to kind of like draw in the layer. So for example, you can erase something here. Wait, it might be easier to kind of go back to the 2D view, and then, for example, I want to erase this label. You can definitely do that. And for different types of layers, you have different tools. So for example, if you have a point layer, so you can add a point layer right here, and then it will give you the tools to add different points. And you can customize the look of these points, and the symbols of these points as well. And of course, you can do this programmatically. For example, if you add a points layer, so if you say viewer dot add points, and you pass it a n by d array, and d is the dimensionality of your image, and n is the number of points. So if you have all these coordinates of the points available in a list or a NumPy array, you can definitely just programmatically add them. And after adding these points, maybe you want to save the results of your annotation. You can do that through this menu here, or you can also programmatically say layer.save points, and it will be saved as well. Yeah, maybe we can also go through an example of shapes. With shapes, you have more choices. So for example, if you want to add polygons, if you want to add rectangles, or if you want to add just a circle, you can do that, and you can also view them in 3D, and they can be available. They can be 3D shapes as well. So now you can see that that circle is basically just one layer in these 20 layers, 40 layers. Yep.
Multiple time steps of the same data set and just constant kind of animation between those two?
Yes. Yes. Are you saying that multiple images from different frames?
Yeah.
Mm-hmm.
Yeah. Those data set on multiple time steps.
Yeah. Yeah.
Going through them will be an
Yeah, you can definitely do that. Right now, we're treating the z-axis as the, we're using the z-axis, sorry. Oops. So what I just wanted to show is that you can use this dimension slider. So right now, we're viewing like z-axis as that dimension, but you can also add a time dimension to that as well, so you can visualize different frames too. Okay, so we just did adding images, adding labels, adding different layers to Napari. But if Napari could only do this, there's no fun at all, right? So now we go to the fun part, which is you can customize the Napari interface, and so it allows you to do many more interesting things to the viewer. So for example, let's just start from the very beginning. You can customize the interface so you can respond to custom events. So for example, keystrokes, you can do that. So you can bind a key, and then so Napari will respond to the keystroke and run arbitrary Python code in that interface. So for example, I just created a few layers. If I don't want these layers, so I just run this. So basically, you use a decorator, and then you bind a event handler to the viewer, and then the viewer will know how to respond to your keystrokes. So I just binded the delete action to the visualization. So if I just type D on my on my keyboard, then you can see that the latest on the topmost layer is now deleted. You can repeat that a couple of times too. And also, because I programmed it, you can see in the status right here, it will show what layer you removed. So there is a whole lot of programmability right here. That's one thing that you can do. Another thing that you can do is that you can also bind to mouse events as well, just like what you do in JavaScript. So this is another thing that you can do. So I'm just adding a layer, but this layer will respond to my keyboard, my mouse dragging events. So if I just do a dragging, so then this layer will just generate a bunch of random noise in that layer. And if you drag it another time, the pattern of the noise will change as well. So there's a lot of things that you can do with this responding to different kinds of events. You can even customize. You can even kind of create your own events, and then have this interface respond to it. Okay, so that's event handling, which is very handy in this kind of environment. So let me just get rid of this. But Napari can do more than that. You can even further customize this interface to do many more cool things. So for example, right now, I think that this image is too dark. I don't like it. But we know that in both OpenCV and scikit-learn, there are a few ways to kind of automatically adjust the contrast of the image. So you can, if you see the image a little bit clearer, you can definitely do that. If you run the next cell, so what Napari does is that it uses this package called Magic GUI to customize your GUI. So you can add, for example, a widget to this user interface. So let's just run it and see what happens. And then you will see that it's actually very, very easy to kind of do this kind of customization. All right, so after running this code, you can see that there is a new kind of panel that showed up, which is basically the widget that we added, right? So and in that, I want to give my users the freedom of using a global or local kind of local algorithms to kind of automatically adjust the contrast of the layer. So let's just see how that works, right? So if we click on Apply Enhancement, and you can see that this global enhancement based on histograms has already been added to. So by doing that, you have already expanded the functionalities of Napari. And also, you can choose local as well, and then apply the same enhancement. The local enhancement will take a while. You will see that it actually showed up as well. So basically, you're adding a toolkit for your users, right? And then you can just package this and then publish it as a Napari Hub kind of plugin. So this is a really cool functionality that I think is very, very useful in Napari because basically you can run arbitrary code in Python and allow users an interface to kind of like pick different parameters for your different functionalities. Yeah, please.
So is there an undo functionality in general, and now in particular, is there anything that auto-handles that for when you're adding custom widgets, or is it the responsibility of every programmer to keep track of any destructive?
That's a good point. Yeah. So I don't think there is an undo there, but you can definitely program it, right? So this is all something that you can do. It gives you a lot of freedom, but I don't think it comes as part of the Napari package. That's what Napari Hub is for, right? You might be able to find someone who has already done this for you, and then you just download the code and use it. All right, so let me just go through this, how you add the functionality just a little bit, because I think this is a very clever way of adding like additional functionalities in Napari. And this is actually the very first time I actually see that the type annotation being useful right here, because the way that Napari works is that it actually uses the type annotation of the function being annotated, so that it figures out automatically what kind of controls that you want to display in your widget. So, for example, let's see, we had a radius control right here. Right, so you can adjust the size of the neighborhood when you're doing local enhancement. So in this function, you just specify it as an int, and it will automatically give you a slider, and then you can further customize that slider in the decorator and say that I want my radius to be the type to be a slider. And the maximum value that I want to allow my user to use is 10. So, and then your slider will go only to 10. All right, so this is a very easy way to kind of add controls to Napari. Yeah, and I wanted radio buttons, so I used a string, but actually Napari prefers an enum. To be added here, but if you specify this type as string and then specify it as a radio button, give it choices, then Napari will complain and say that you just specified, you gave me a string, but I want a radio button. I want an enum, but it did that for you anyway. So it is a very intelligent way of figuring out how do you do the interfacing. And also, you can use Napari's own types in this function as well. So I just passed image as a Napari.layers.image as an image layer type, and then what Napari did is it automatically generated a dropdown that allows you to only select layers that are images. Whoops. Yeah, and then also with return type, you can also return a subclass of the layer type, and Napari will figure out that the default behavior is that when you return a layer, Napari will automatically add a layer to the viewer. So that's why these are added as new layers. And you can see that within this image dropdown, you can only see layers of type image, and the labels type are not shown here. So it is a very intelligent way of doing like user interface customization. So yeah, and that basically ends my presentation about image like interface customization. Any questions right here before I move on to the next section, which is also pretty cool? All right, okay, so let's move on. So let me just close this. And the task right now has changed. Okay, yeah, please go ahead. Yeah.
Can you do like multiple images like a montage?
I'm sorry?
Can we view multiple images like a montage? Like if I want X, Y, Z, like all together in a one image? 3D, but as a separate image.
I think you can do that, and also there are ways to overlay layers on top of each other, so you can create a blending effect too, just like what people do in Photoshop. So that's pretty cool as well. Yeah. Mm-hmm.
Just because you just clicked on the GUI to eliminate that viewer, is all the data that was in it now lost, or does it still exist as a Python object if you want to grab something you forgot?
I think it is lost, but let me just check. We can see if the viewer is still there. Yeah, that viewer is still there. It's not deleted. But it might not be able to, I don't know how to, maybe there's a way to kind of load that interface again and have all of your data in there. And we can also check if all the layers are in there, because the layers are just represented as a list, right? Yeah, it's all there.
But then that also suggests that Python will not automatically garbage clean it. So if you happen to have a bunch of viewers you didn't kill in the script, they'll still be taken off that method.
That is true, yeah. So you can use viewer.close to kind of like delete that object. Yeah. All right, so let's move on. And now we do need another viewer. So maybe let's just close that viewer. Yeah, oops. Yeah, it says it has been deleted. So, okay. Yeah, because this task we need a lot of memory for. So we have done image prediction on small parts of the brain, right? But we have also done image segmentation on the entire whole brain image, and these can be very, very large images. So Napari can also handle that by using DSC arrays and kind of just lazy load whatever image that you want to display at the moment, so that you can get around that memory limitation. And the way to do that is actually very, very easy. You just substitute NumPy arrays with DSC arrays, and Napari will handle that for you. So we're just loading a bunch of DSC modules. So what you will need is DSC imread, and also you can also read from a ZAR array as well. So whoops, sorry, it's not. Okay, so now we can inspect what is our very large image. The very large image is a 32 gig huge 3D image with 581 slices. And we also have a very large label that is also saved on disk, but you're saving it as a ZAR array. ZAR is basically the backend of is a distributed kind of storage backend for arrays like NumPy array. So basically, it does automatic like chunking for you, and also when you save the arrays to the disk, it will also provide compression. So this image, this label, if you load all of them in the memory, it will take 64 gigs. But because this is a very sparse array, ZAR provides about a 200-time compression. So on disk, it's about 300 megabytes. All right, so now let's just load this and see if, this is a GPU instance. It probably has 7 gigabytes of memory. Can it handle such a huge image? Yes, it's loading. It's loading. I think it will work. Let's see. It's loading. Yes, it's loaded. So basically, it is just showing a slice of the whole brain to you on the z-axis. Again, you can do, if you select the image, you can do contrast limit to make it look a little bit brighter. And you can also zoom in. And you can see the predictions. So this is actually very useful because otherwise there's probably no way to kind of like visualize huge images like this if you don't kind of load them all into the memory. And also, but there's one thing that you cannot do right now, which is to toggle this 3D view, because that will try to load all of the images in the memory, and this will definitely blow up your memory. And I'm not going to, I tried it, and it blew up my Oscar instance, so I'm not going to do that right now. But there are also ways to get around this. So I think there is a way for you to kind of save downsampled images of the original, so that it works like Google Maps. At different scales, it loads different different arrays, so that you can actually do the 3D with a lower resolution image if you view it from like a distance. Yep, please.
Sorry, I just got a little confused on
Mm-hmm.
where you're saying the limitations are. 'Cause the
Yeah.
whole point of DASCs is to load something that is bigger than your memory. So
Right.
what you're saying is somehow Napari's communication with them is not enough to understand what to load or not load for multiple slices? Is that the issue?
No, not that, because if you, for example, if you want to kind of like have a view of that, depending on the way you chunk, right? Sometimes you're going to have to load all of it into memory. So there's different ways of doing the chunking. So if you, for example, only want to see this part, maybe you want to kind of like do chunking so that when you view it in 3D, Napari only loads these chunks and it does not go over your memory limit. But as it is being chunked right now, and let's go back and see. So right now it is using every slice on the z-axis as a chunk. So for example, if you want to do like a 3D view, I think it is very hard for Napari to figure out how many slices I need to load, because you might think that you want to see all of these slices, right? So there's no way to kind of get around that. But you can definitely have like a different chunking mechanism to make this work. And another mechanism is that you can save downsized images so that at different resolution, it loads different resolution images. So you can get around that kind of limitation as well.
So just to push on that just a tiny
Sure.
bit more. So like in computer graphics, like in a game engine, you define typically this volume that's like my minimal Z and my maximal Z, which I'm going to look at things.
Yeah, yeah.
And that gets mapped into whatever your projection will actually be. So,
Right.
So what you're saying is that, at least out of the box, maybe Napari doesn't know how to do that, convert that to slices, but maybe there's something on Napari Hub or something?
I think so. I think so. Yeah, I think so. And also maybe, what I'm also saying is that maybe this is not the best chunking scenario. Maybe you don't want to save your images as just slices on z-axis, right? Maybe you want to save your image something like this, small little cubes, right? And then maybe when you're doing 3D visualization, Napari can figure out, oh, you only need these cubes, and then it will not go over your memory limit. But again, with only 7 gigs, I was just very afraid that at some point it will go over memory limit. So that's why I tried not to do that. But there's definitely ways that you can try to get around that limitation. Yeah.
As I know, we do have tools in Oscar that are able to render data sets that are way bigger than regular memory on computer. So we have been able to render in 3D data sets over the 300 gigabytes using Oscar memory. So
We're going to follow up with you after.
and as a matter of fact, the next DSCov is all.
All right. Okay. So here's the last thing that I want to show is something fun that I just did last night. So OpenAI just published their DALL-E API last night. So I was thinking about, maybe I can do image generation in Napari. So this is what I did. So let me just close this one and load this one. So right now it doesn't do anything, but can someone give me just a prompt to generate that image? Any prompt? Any prompt? Okay, so maybe we can do.
I've run out of memory.
I'm sorry?
I've run out of memory.
I've run out of. Okay, let's see what DALL-E says. Does that make sense? All right, let's try it again. Makes sense, right? All right, let's try it again. I just love this. All right. So basically, you just get the prompt, right? And on the back end, you basically just querying the OpenAI API. The DALL-E API will generate images for you, and you just get that image from that URL. So the code is actually very simple. You can do it within a few lines. This is what it does. You use the OpenAI to do image generation. Just pass prompt as your prompt and specify different sizes. Actually, you can have your users specify sizes as well, right? And you can choose like how many images you want to generate, and then put that all into your visualization. Yeah, go ahead.
Is OpenAI model installed in Oscar, or is a package?
It is a package. It is a package. Yeah, you just need to install that, and yeah, it's a very it's just like any other Python package you can install. Yeah. All right. Any other questions? All right. If not, thank you so much. This has been fun. So really appreciate you coming. And I think there's still some pizza. So if you haven't had, please feel free to grab some more. Thank you all so much. Thank you.